In problem 4, we have two functions and we're trying to create a composite function. In this case, we have f of x equals 1 over x minus 1, and we have g of x equals the square root of x plus 9. We're trying to create the function f of g of x, which we could also write as f of g of x in this way. So we're taking the g function as an input into the f function, and we've written that here. We replaced the g of x with its equivalent, square root of x plus 9, and that's our input of the f function. So since x was the input of the x function, we replaced the x, and notice I always like to put the parentheses around. We replace the square root of x plus 9, and that becomes our new function, our composite function. We also want to know, do we have any restrictions on the domain? What inputs give us viable real number outputs? Well, we have two types of restrictions in this case. One, we have a square root, and for square roots we know we need positive inputs. Otherwise, if we have a negative number input, we get an imaginary result. And since we're not wanting those in this case, we need to restrict x plus 9 to being only greater than or equal to 0. Okay, it can be equal to 0. We can take the square root of 0, and that's just fine. Okay, that quickly shows us that our x's have to be greater than or equal to negative 9. And we have one more restriction. Note that we have a rational function here where we have a denominator, and we never want to divide by 0 because dividing by 0 gives us an indeterminate result. I've written that here. So we wouldn't have a viable solution if our denominator here is 0. So we have to restrict that and say the square root of x plus 9 minus 1 cannot equal 0. Well, then we can add 1 to both sides, square both sides, and then subtract 9, and we see that x can't equal negative 8. Okay, so the lowest value that we can put in was negative 9, because x has to be greater than or equal to negative 9. So it can be equal to negative 9. That's why we use the square bracket. Then we can have anything from negative 9 up to negative 8, but we can't have negative 8, so we're going to take that out. But after negative 8, anything's free. So we move from negative 8, not including it, that's why we use the parenthesis, the open bracket, on to infinity. And this union says we can be in either of these sets. Okay. So that gives us our full domain.